Hey there, pre-calc. Yup, it's me, your favorite internet pre-calc teacher, back again with another lesson from my dining room. Now with new and improved video features, such as a face cam. Now we can have this personal face-to-face connection, kind of, sort of. Well, you can see my face anyway. I can't see yours. I still have to talk to this camera and pretend that you're there. You're my imaginary students out there, but we can still get your education through the cyber world. Well, I hope that last series of videos was helpful. I'm going to do my best to make this one equally or even more helpful. We're moving on into module 6.04 about dot products of vectors. So we're still in vectors. Okay. So here we have the standard unit vectors, which I'm going to show you. This is something I probably should have showed you in the last section or the last series, but I skipped it because I noticed it wasn't in the quiz. Let's see, some of you actually messaged me on Remind saying, what is this stuff in the Canvas lesson about standard unit vectors? It doesn't make sense. You didn't make a video on it. Well, that's why, because it didn't show up in the quiz. Unfortunately, it is going to show up in this coming quiz for 6.04, so I decided I'd do a video on it. And it's good to see this because you'll often need to know what the standard unit vectors are in future classes that deal with vectors. Okay. So without further ado, let's jump right in. Standard unit vectors are I and J. I and J. Okay. I, not the imaginary number I as in the square root of -1, the standard vector I. Okay. I is this vector. Every time you see I, that's the vector, 1, 0. It is literally this vector, which is 1 unit long, okay, in the x direction. That's I. Okay. J is the same thing, but in the positive y direction. Okay, that's J. I is a unit vector in the x direction, and J is the unit vector in the y direction. Okay, why do we care? Well, these vectors, it turns out, if you take a what we call linear combination of these two vectors, you can make any vector you want. If you add and subtract multiples of these vectors together, you can get any vector you want on the xy plane. Okay, so let's do an example of that. Okay, just remember, I is this vector, J is that vector. There they are in component form for you. Okay, let's do an example. Let's suppose I have the vector, I don't know, -4, 3, and that's my vector v. Okay, just a new vector. How do I write that as a linear combination of the standard unit vectors I and J? Okay, well, first let's graph the vector v. It is 3, -4 in the x direction and 3 in the y direction. So this is vector v, starting from the origin. There's vector v. Okay. Now, how do I get to vector v only using i's and j's? Well, since v is -4 in the x direction, which standard unit vector goes in the x direction? I does. If I take a negative I and another negative I and another negative I and another negative I have traveled far enough in the x direction to make up the x component of v. Okay, so -4 i's will get me there, and then +3 j's, a j plus a j plus a j, will get me to the endpoint of vector v. Okay, so how do I compile -4 i's? Well, I take I and I multiply it by -4. That will give me this vector right here that goes -4 in the x direction, right? If I take this I vector, multiply it by -4, it's going to get me all the way over to here. Okay? Now what? Take -4 I and add, since I've gone -4 I, now from that endpoint I want to go +3 j, add 3 times the vector j. And now I have gone up 3 units in the y direction for a final destination of -4, 3, my v vector. Okay, so this is the linear combination of, what are they called again? Standard unit vectors. Okay, that's how you write v as a linear combination of the standard unit vectors. So when you get to your assignment for this section, the recommended problems I give out, and it says find the dot product of these vectors, sometimes you'll be given those vectors in regular component form like this with these pointy brackets, but sometimes you'll be given the vectors in standard unit vector form like that. Okay, so if you see this vector, I don't know, 7i minus 12j, what's that? that's just one vector, 7 in the x direction and negative 12 in the y direction. So really, that's the same thing as this vector, 7, negative 12. And you calculate its magnitude the same way, you figure out its angle of direction in the same way, you treat it the same as you would this vector right here in component form. Okay, so now you know about these standard unit vectors I and j, and when we get to the third dimension will introduce you to k, which is 1 in the z direction. Okay, so then we add in this third component, right? X, y, and z, x, y, z. This one has an x and a y component of 0 and a z component of 1, but we'll get to that when we get there. Okay, that's it for this one. See you guys in the next video. Bye.